This is our capstone project, and we're Team ARecipe. My name's Andy.
My name's Nicholas.
My name's Chen.
I'm Curtis.
My name's Pooja.
I'm Char.
Our team consists of 6 software engineering foodies and proudly supported by home cook advisor Roy Eagleson. With various experiences in cooking, we're passionate and willing to explore different, healthy recipes, keep the ingredients safe, save money, and share the cooking education with everyone. So the problem we're trying to tackle today is every year, Canadians dispose over 15 billion tons of food and leading to average of financial loss of $1,700 per adults, and the number goes up significantly for Canadian college students. Food waste is often the result from people not knowing what to do with their ingredients and causing them to be inedible from being unused for too long. Additionally, 65% of Canadians are overweight or obese, largely due to frequent consumption of fast food and experience to cooking healthy meals at home. And we aim to tackle that with ARecipe. Our solution empowers users to discover recipes tailored to the ingredients available in their fridge, allowing them to make good use of the food before they go to waste. It provides the user with a simple, intuitive user interface that allows them to find ingredients, find recipes, allowing them to avoid spending more money on unhealthy fast food. Users are able to open the app, take a picture of their fridge, desire cooking ingredients, and the app will return a list of recipes using those ingredients. We have a very simple architecture flow for the user with intuitive access to each interface, such as camera scanning, recipe searching, and cooking in real time. Our project facilitates several features through user authentication, Webscrapper for the recipes, machine learning to scan the ingredients, and very user-friendly interface for the users. And here we have a slide of mock-ups of our platform, and our colleagues will dive in deeper into each interface and their features.
Now we will talk about the development of our application's user authentication system, employing Angular for the front end, Node.js and Express.js for the back end, and MongoDB for the database. Users can register for our application by providing their email address and creating a valid password. With the implementation of input validation, our app ensures data integrity. Upon sign-up submission, passwords undergo encryption using bcrypt with 10 rounds of salts, improving security against potential breaches. Encrypted passwords are securely stored in our MongoDB database, ensuring the confidentiality of user credentials. Users authenticate by entering their registered email and password. Upon successful authentication, grants access to the application's homepage. Our user authentication system prioritizes both security and usability, utilizing Angular, Node.js, Express.js, and MongoDB. With a focus on encryption and seamless user experience, we ensure a safe and efficient authentication process for our users.
All right, the key feature of ARecipe is our image capture. This was created using the Angular webcam module, and it allows users to select the camera they would like to use. For example, the rear-facing or the front-facing camera. The user will then take a picture of their fridge, and the image is saved as a data URL and sends that data to Google Vision API for further processing.
As Nick said, the pictures are sent to Google Vision via an image data URL. The image is sent to Google's cloud platform, which identifies possible ingredients and returns a set of vertices for each ingredient found. From there, we will then process the image, for example, adding bounding boxes that show each ingredient found, as well as labeling each box. All of that, plus a list of ingredients found, is sent to an after machine learning page, which will then display that information to the user.
We also have a manual ingredient addition and editing feature. This allows users to exactly specify the ingredients they currently want to cook a meal with by adding, editing, and deleting ingredients to and from a list. It supports any and all ingredients the user might have, with multiple quantity types for the ingredients. The form provides input restriction and validation, preventing the user from making simple mistakes such as entering negative ingredients or entering any kind of malicious code. When the user is done creating their ingredient list, it is sent to the Webscrapper component to generate matching recipes.
When the user is cooking, one of the most annoying things is having to read the author's life story before getting to that recipe. To combat this, we developed a Webscrapper, a simple script that is compatible with any recipe website link. This provides a quick and easy method for us to get information from websites, including cooking time, ingredients, recipe steps, number of servings, and nutrition facts. Once the recipe has been selected and the user wishes to start cooking, our in-app timer allows users to easily set the cooking time without leaving the app. The timer is persistent so that the user can navigate to other components within the app and still be notified when the timer is done.
Finally, we have the in-app Google search, where users input ingredients into a search bar, and the application scripts Google search results to display the first 4 recipe titles. Puppeteer is used to automate a web browser, simulating a user's search on Google for recipe based on the input ingredients and scraping the titles of the top results. CORS, which is shortened for Cross-Origin Resource Sharing, allows the front-end Angular application to make secure HTTP requests to the backend server by setting specific HTTP headers that enable cross-origin requests. This overcomes the same origin policy limitations. Finally, the RESTful API designed with Express.js on a Node.js backend provides structured endpoints for the Angular frontend to retrieve recipe data, where the Angular service make HTTP requests to these endpoints.
In the beginning, our group was very ambitious and tried to incorporate many huge buzzwords like artificial reality and our own machine learning model. However, we didn't have enough time or knowledge or resources in these areas. Thus, we had to reduce the scope of our project and just focus on generating recipes based on food that we have. With the AR integration, we initially wanted to use Unreal Engine to generate an artificial reality model to display tutorial videos to teach users different culinary techniques. This process became very resource intensive and was not compatible with our application, as we wanted to be lightweight and to be used on a mobile device.
With our ML integration, we initially wanted to use an in-house machine learning model via a variant of YOLO version 8. However, time and time again, this machine learning model failed to meet performance expectations, oftentimes getting food or ingredients misidentified, such as calling cabbage an alcoholic beverage. Another limitation we had with our machine learning model is that training time was limited. It was also very difficult to integrate to our existing project and would have required us to push it to a cloud platform such as Google's Google Cloud Platform. Thus, the switch to Google Vision was made, as it is super simple to integrate with our current app, although Google Vision does have some issues. It has been much better than our previous ML model. Next up, here's a demo of our application.
You know what I always say, anyone can cook. All you need is a recipe from ARecipe. Thank you.